Clouds for Revit modeling discussion. My name is Kurt Marino. I am a CAD manager and blogger with the Kung Fu Drafter. And to let you know, today's discussion is being presented by Cadalyst and is sponsored by Leica Geosystems. And I would like to take a moment to introduce my co-speakers on this panel discussion. And let's start off, excuse me. Oh, I apologize. So again, my name is Kurt Marino. We're here to discuss the use of optimizing point clouds for Revit modeling. And to let you know, we'll be taking questions throughout the panel discussion and all the way at the end. And if your questions do not happen to get answered, we're going to do our best to get to those individually, or you can follow up directly with Leica or Cadalyst itself. So allow me to introduce my panelists with me. I have Mr. Ben Bennett, who is the Cto of Digital Surveys, and which is a subsidiary of eService. Ben, would you like to say hello and tell us a little bit about yourself?
Hi everyone, my name is Ben Bennett. I'm the CTO for a company called Digital Surveys in the UK, and we have a service called eBIM specifically geared to creating as-built building information modeling models from point cloud data. A quick bit of background, we were just a traditional survey company, and we got into laser scanning about 4 years ago. We got our first scanner and really embraced it since then, and I utilize laser scanning on everything that we do. And the natural progression from that going forward was 3D models and as-built BIM models.
Fantastic. Our next panelist is going to be David Langley. David is with Leica Geosystems and is an application engineer working in software product development. David, would you like to say hello and tell us a bit about yourself?
Sure. Hello, everyone. My name is David Langley. I am an application engineer with Leica Geosystems. I've been with the company now for about 2 years. I have about 12 years in the surveying and CAD industry. And the past 9 years, I've been focusing specifically on laser scanning. And I was one of the main contributors in the product definition of CloudWorks for Revit.
Well, that's fantastic. Okay, our next panelist is going to be Mr. Michael Harvey, who is also employed with Leica Geosystems and is a product marketing manager. That's actually a nice little title to say really quick, product marketing manager. Michael, would you like to tell us a little bit about yourself and say hello to our visitors?
Sure. Hello, everybody. I'm Mike Harvey. I joined Leica Geosystems back in 2004, originally as part of the sales team in the Southeast, but since then I've taken on this role where I look after the business in the NAFTA market. I'm in 12 years of surveying experience before I came to Leica, and I've been in this position for quite a while. So my passion is laser scanning, so that's a little bit about me.
Fantastic. Our final panelist, but last but not least, is going to be Mr. Jason Waddell, who is a bid manager for the VEC Group. Jason, would you like to tell us a bit about yourself and say hello to the attendees?
Sure. Hello, everybody. My name is Jason Waddell. I'm with the VEC Group. We're an architecture and construction firm, and I've been with them about 4 years. I've been doing laser scanning for about 4 years, modeling specifically with Leica CloudWorks in Revit for the past 6 months or so.
Fantastic. We seem to be catching a little bit of echo in our sound, so we apologize for that. Our organizers are working hard to take care of that. But while they are looking into that, we're going to go ahead and proceed with our discussion. As you all know, we're here to discuss optimizing the use of point clouds for Revit modeling, and we have a great collection of Revit professionals and developers, along with a great audience of people who are either current Revit users or looking to get into Revit. So let's start out with, and I'm going to toss this question to Mr. Ben. What kind of software is currently available for the scan to Revit / scan to BIM market? And what are the limitations? What have been the limitations that you've seen of these? What has been your experience been?
Right. Well, it's been very limited up until now, and one of the big problems we had was a lot of our clients were looking for as-built surveys or measured building surveys in a Revit format, and we really struggled to find a way to get our point cloud data into Revit. Now this all changed when 2011 came out, because at least that gave us native point cloud support within the software. Up until that, we had to use lots of workarounds where we'd either model in a separate piece of software like AutoCAD 3D or Rhino and bring the model across and then remodel it in Revit, or create scaled images from the point cloud, bring those into Revit and model scaled images. All of them were pretty slow, laborious workarounds and just not very efficient. So with the native point cloud support, that really opened up the avenues for us to begin working direct with the point clouds, and it's really transformed how we could actually benefit from using laser scan data in Revit. And obviously, as things are progressing now with software like CloudWorks Revit coming out, that's really taking it forward. But there isn't very much on the market whatsoever. You're very limited with the workflows and the ways of getting that point cloud data into Revit at the moment.
So you pretty much feel that it was the introduction of native point cloud support in Revit that opened these opportunities, but you're still finding that your options are limited by the availability of software from the vendors.
Yeah, that's right. I mean, we also used a lot of other software, main one being Point Tools, and we were always hoping there might be a plugin that came out for Point Tools to bring point cloud data into Revit. That never materialized. And one of the other issues is just simply the different file formats and transforming data into the right format to try and get it across. We would be working with different scanning formats, and we'd have to export to different file formats, index it in, and bring it in. It's been quite a time-consuming process. The native support with 2011 made that certainly easier. You know, you would export a PTS file, you could index it, convert it to the Autodesk PCG file format, and bring it in. That certainly started making working with point cloud data more feasible. But there's obviously still a lot further to go with the development of point cloud support within Revit.
Okay. Jason, as a BIM manager, how do you feel about the points that Ben has brought up?
I would agree. I think one thing that I had to do previously before CloudWorks came out was, we'd model the existing buildings off of as-built drawings. And then we'd use tools like Navisworks or Horizontal Glue and overlay the model with the scan. If we found any differences, we'd measure it, go back to Revit, make the adjustments, bring it back in, go back and forth. And a very laborious task, took lots of time. So I would agree. There's limited tools out there now, but they're much better than they were 3 or 4 years ago.
Okay. Michael, as a project manager or product manager, is this the reason that Leica Geosystems looked at this market and realized that there was room for not just an additional tool, but maybe a superior tool in your view?
Yes. So through several of our users conferences that we've had over the years, that one of the major requests from users was having some sort of CloudWorks plugin for Revit. And then also, Leica as a global company, looking, keeping their ears to the ground that the BIM world is definitely the hot topic these days. So it made sense to make the CloudWorks for Revit plugin. And then by doing so, we solved some of the importation pains, if you will, that the market is having. So that the working with the point cloud becomes a lot easier for everybody.
Fantastic. Now, David, you're an actual developer, so let me ask you. You've heard from some users, and of course, you know Michael, and you understand the Leica corporate point of view. But as a developer, how do you bring, the mammoth amount of experience and history that Leica Geosystems has in the scanning industry to a new industry? How do you translate that for users? Was that difficult in creating the product?
So to be clear, I'm not an actual software developer. I kind of write the specs for what software needs to be created by the developers and kind of manage that and oversee how the software is being built. So just wanted to clarify that.
Oh, okay.
So, the way that the CloudWorks product works, it's very similar to the rest of the CloudWorks family. So it's really nothing, too new to us. It's just now that it's able to be ran on a different platform. So, things really weren't too different for us. It's just coming up to speed on, some tools that may need to be specialized to work, in the manner of how Revit works and things of that nature. So, it's still a lot of the same tools that most customers are used to using with the CloudWorks family, just on this new platform.
Okay. So now that we've got our conversational coffee cups all nice and warmed up, CloudWorks is an existing product that is now available on the Revit platform. So obviously the point that we're all here to discuss is the use of point clouds. So if you could just take a moment as a product developer, as opposed to a software developer, I apologize for that. What exactly is Scan to Revit, and how does it work in basic terms for those of our listeners that may not be as well versed?
Sure. So how it happens is you go out into the field, collect the data from the laser scanner, bring it into Cyclone, which is our main product, and once that's the database that has the point cloud engine and everything in it. So once you have all of the data in the database form in Cyclone, and then you can go ahead and install CloudWorks on top of Revit or AutoCAD or MicroStation or what have you, and then you can then browse to that database that is in Cyclone, and then just open that up, and then it uses the rendering engines in those platforms, but still is running our Cyclone main engine that has an unlimited amount of points that you're able to load into it and to view and whatnot. So Cyclone is still managing and feeding all of the data into these platforms, and then you're able to create limit boxes and slice them up and kind of work with them in those platforms in that manner.
Okay. Now, Ben and Jason, as actual users on the ground and business owners or business people who are looking for the best and most efficient method to do your project, obviously you're focused on time. The less time you can spend on a project, the better profit you can turn. Is the workflow that David is describing something that you find attractive? Is this something that you look at and say, hey, you know what, that's cutting a lot of steps out for me, and I know that I can produce a better project with a better profit margin?
Yes, I think for us, certainly one thing we want to do is just simplify the process that we're doing and simplify the different software package that we're using and bring that down to as minimum as we can. So it is an attractive proposition to be able to bring everything into one centralized area within your Cyclone database and have that accessible to various different software packages, whether it's Revit or AutoCAD, using the CloudWorks plugin. One of the issues we've had in the past is just managing a large project. You may have up to sort of 600 scans on a large building. They're split down into maybe floors or individual areas. They're all indexed as individual point clouds, and you have to then have multiple point clouds indexed within Revit. And Revit's native point cloud support is limited with the amount of point data you can bring in. I think the maximum is about 50 gig. But on top of that, it also reduces the amount of points which are displayed at one point. So we're reducing our data down to get it in the first place, and then it's visually degraded via Revit anyway. So by able to simplify the process, keep it in a central area, but then still be able to bring in the full quality of the point data is very attractive to us.
Okay, and Jason, is that similar to you? Is that a similar story in your situation? Are you finding the same things, or are you having a different experience?
No, I think that's exactly the same experience we're having. CloudWorks simplifies the whole process. You're able to gather multiple scans and save them as a project, so you don't have to open them individually every single time and kind of arrange them inside the model. Everything is registered, comes in the right spot the first time you open it. Plus, from a modeling perspective, once you bring the scans in, you're physically modeling over the top of the existing conditions the first time. so you know it's exactly what's out there from the get-go, which is great.
Okay. Well, and that does sound like a much simpler process. Now, one of our questions coming in from our attendees, as long as we're discussing workflow, is does CloudWorks work independently with Revit, or do you also need to have the Cyclone application? So I guess there is, that's to say, is CloudWorks a standalone application?
So CloudWorks is not a standalone currently. You do have to have a version of Cyclone installed. So when you do have a license of CloudWorks installed, you do get some other functionality of the Cyclone as a viewer. You're able to do some importing and exporting with it as well. However, you do need Cyclone installed on the computer that you're running CloudWorks on.
Okay. To add to that, that the version of Cyclone that you have installed can be unlicensed, so it can be running in the Cyclone Viewer. So it's basically the free version of Cyclone.
Oh, well, that's fantastic. I'm sure that that's very attractive to a great many of our attendees. Now, along with that, the topic of viewers and codependency, what plugins will be made available for other BIM applications? Do you have any plans for this on the horizon? What are your current plans for kind of sister applications to CloudWorks?
In the CloudWorks product itself, or are you looking outside of CloudWorks if we're thinking of anything else?
Well, let's see. My exact question is, what plugins will be made available for other BIM applications anytime soon? So I guess the question is, what platforms is CloudWorks available for, and what do you have plans for in the future?
Currently, it's available for all the AutoCAD platforms, MicroStation, Revit. All of the large CAD platforms.
Okay. Well, we've been hearing a lot about the product and the workflow, and I'm sure that our attendees would love to see a demonstration of CloudWorks. And David, I believe that you have a demonstration that you'd like to go ahead and share with us. So if we can get controls sent to you, I think that everybody would love to see this application in action.
That would be great. Okay, I believe I am now sharing my screen. Does that look good on your end?
It looks great on my end.
Okay, so what you will see here is I have Revit MEP opened up here, and you'll see the Add-ins tab. We have all of the CloudWorks tools underneath that Add-in tab. Keeping in mind, too, I am not a Revit expert, so I am a CloudWorks expert, however. So I'm going to kind of just run through the functionality of CloudWorks and kind of show you how it integrates into Revit. So here you'll see, starting out on the left-hand side of our tools, we have the ability to import, open, close, save projects. So this is the actual point cloud data itself. So when we do pull it in, and any segregation we make of the clouds, whether it be a box, a limit box, all of those get saved, and you can name them and things of that nature, and then you can save them out. So when you come back to this project tomorrow and you open up that project, all of those clips will be there. So I'm going to go ahead and open up a new model space. So here you'll see this is now going to be looking to our Cyclone Viewer. So we're going to browse. So you'll see, first off, we have full access to all of our databases that we have currently loaded into our Cyclone project or into our Cyclone product. I have a shortcut here that links up to the actual model space that we're going to be importing. I'm going to go ahead and open up this one. And here you will see now it's importing the points. Again, it's going to be using Cyclone as the point cloud engine. So, just like that, you're able to get the points in there. There's no need for any kind of, export out, convert the points, and then, re-import them into Revit itself. So now it's just looking to Cyclone to display all of these points and to run the point cloud engine from Cyclone. So I'm going to go ahead and change the color of this point to the intensity view, which is a little bit more common to what people are looking at with the point cloud. And then we're going to go ahead and work. I'm going to just work on this. This is a rooftop area with some chillers, so I'm going to go ahead and just work on this chiller area. Oh, it looks like there's a little bit of a lag time on your end, so I need to slow down a little bit here. So you'll see now we have some clipping options. So I'm going to go ahead and just do a simple clip of the point. I'm going to just work in this area here. So there you see we'll work on this chiller. And then we also then have the ability to set levels. So I believe all of you out there know how important levels are to Revit. So you can set them by user if you know what elevation you want to set, or you can set them by point. So if we go ahead and just set one by point, you'll see if you pick on the point cloud, it's going to return the elevation. We can give it a name. I'm going to store that in our floor plan, and we'll say OK. So you'll see it generates that new floor plan level over there for us. So next thing I'm going to show is a few of the clipping planes. So here we can create a plane that we're going to do a slice on. So you'll see it just takes a slice of the point clouds out of that area that we clipped out. So then you have the ability to move forward, and it's just going to step the point cloud up, working its way up, holding that that distance that you specified. And then so if we are going to go into our floor plan, so say we want to build a wall around this, we'll just pretend that this is a wall and not the chiller there. So if we go to our chiller top here, that I generated a few other levels previously, so we don't have to go through and generate all these for time's sake. So if we open that up there, you'll see it takes us to our top level, the base of our chiller. And let me go ahead and open up a couple different views here so you can see what's going on. So now you'll see what you do, just with very similar to all the other CloudWorks family, is you're going to just kind of use the points in the background to start building your model from. So if we want to generate some walls from this, go ahead. Save that out. Okay, so now that we're in our wall generation, you'll see we're going to just use our constraints for the top and bottom of chiller. And then you can just start. Then you can snap to the point cloud if you wish, or you can kind of just use it as points in the background. There you can see on the right-hand side of the screen as well, it's generating our walls for us as well. Is everything coming through all right on your end?
Everything is looking great. For somebody who's not an expert, you certainly make running through Revit look very simple.
Well, thank you. All right, so continuing on, that's just some basic things, so you're going to be just using the point cloud, kind of as a background reference data, and then you're just going to be using mainly all of your Revit tools to generate your models from the ground up, whether it be walls, floors, ceilings, things of that nature. So let me continue on quickly getting through the rest. You'll see, so we have some other clipping features, some different boxes, different limit boxes, and then all of these get stored in this clipping manager as well. So you can come in here, and so we can turn off our slice. So there you can see we're back to our original box that we generated.
Okay, so all of this viewing is non-destructive. We can easily access those points that we've eliminated from the view in this clipping manager. Am I understanding that?
Exactly. Yep, you got it.
That's fantastic.
So you can go ahead and you can save, rename these and save them. The thickness, if you have a specific thickness you want to use, you can change that to say 3 feet. If we go ahead and turn that back on, So then you can kind of do some QA as well. You know, if you work your way back up that point cloud, you can see how it'll just move the points up the point cloud. We're bringing us, this is a good point here where we can work on some of these points here for the pipe as well. So in MEP, if you are using CloudWorks, you'll see we do have the ability to connect a pipe. So what this is going to do is it's going to actually insert a pipe placeholder, which is native to MEP. So it gives the ability to once you generate these pipe placeholders, it's very easy to then convert it to an actual pipe. So I'll just quickly show you how that works as well. So go ahead and start that. Oops, I'm sorry, that was connect pipe. So we want to generate a pipe. So I like to use the box so I can kind of specify what points it's going to use to fit. Just highlight our points. Oh, that's pretty ugly, huh? Let me try that again.
That's a really big pipe.
That is, isn't it? Let's try that one more time. So we'll go box. Oh, that's not good. You know, it may be because I have this, let me try and get out of this slice. It may be because I'm in this slice mode here. Let me just take a look at some of these points from a box.
Yeah, it just seems as if isolating these points is just magical. I mean, it just happens so quickly.
There we go. That's a little better. So it must have been because of something to do with the slice that I had turned on. So since we're looking there, you'll see how it fits those pipe placeholders into that pipe. And then so what you can do is we can turn those points off pretty easily. We can go and connect them. Now you see they're connected, and they're still pipe placeholders. So then once we want to convert them, we can go and check and see what it looks like. We're working with a 6-inch in diameter pipe there. So we can then highlight our pipes. Now we're ready to convert them. And there you see we're able now converted those over to a true pipe. And then we can go ahead and just purge that temporary geometry. And now we're just left with our pipe. Turn our point cloud back on. There you can see our pipe. So that's just a few, you know, we have a few of those tools that are specifically built for Revit, working with the point clouds. So we have the ability to fit work planes to a surface of the point cloud, so you can then start working on a work plane. We have the ability here to fit sections. So if you have a slice of the point clouds and you want to go along and do a building outline, you can you know, do a rough outline of the building and have it go and fit that line work to the point cloud itself. Just some other, you know, more visual tools. You can have the ability to turn the point cloud on and off. Can change the density, can change the color, and you know, that's really just the quick and dirty way of, you know, running through what you do at the point. But for the most part, you know, you're just using CloudWorks to more or less, you know, break down the point cloud to what you want to work with, and then you're then using, you know, your traditional Revit tools to continue on building your model.
Well, I tell you what, that's really fantastic. You can definitely see how you could quickly assemble this chiller example that you just showed us in just a few minutes.
Yeah.
Now, let me ask you, and this is, I think, one of our questions coming in. So the Cyclone Viewer injects the points into the Revit file. What type of overhead does that add to the Revit file?
To the Revit file itself, it doesn't inject anything to the Revit file itself.
Okay. Now, Ben and Jason, I've seen what's happening here. Is this pretty representative of the types of uses that you have for CloudWorks and the projects that you work on?
Yes, definitely. That's the way we would normally do our workflow. The big advantage I can see straight away here is just the visibility options which CloudWorks has available when we're working with the native point cloud support, the point cloud doesn't bring in any intensity values, so you're left with just a flat gray color on the point data, and that makes it very hard to visualize or interpret what you're actually looking at. So being able to actually see the intensity values and adjust the point size, and those extra options will make interrogating that information much easier.
So Jason, does the easier interrogation of the incoming data to build your models, that must be attractive to you?
Yeah, I think the the color portions, like Ben mentioned, are key. The intensity, the grayscale, and the color as well. Being able to see really exactly what it is you're trying to model is really beneficial.
Now, for myself and some of our listeners who may not be as well versed, what is the significance of the intensity? Why is the ability for CloudWorks to display that intensity so beneficial?
The intensity is the reflectivity of a surface that's been scanned, and it's different depending on distance away from the object that you're scanning. But being able to see the point cloud in the intensity value really pops out the detail within that point data. So if you're looking at a certain surface, by viewing at intensity values and just playing around and tweaking those, you can really pop out the data to see in a lot more clarity the area that you're looking to model.
Okay, that's fantastic. Let me pose this question to Michael. Now, as a product manager, I'm sure that you have people asking you similar questions all the time. But what are the hardware requirements for a scan to Revit workflow? From the scanning mechanism itself, and then also the desktop hardware, what type of requirements would our users be looking at?
Sure. Well, as far as hardware scanning equipment, of course, us being Leica would always prefer us to be ours, but Cyclone will take in other scanners that are on the market. The main thing, as long as you get the data into the Cyclone software, then you're pretty much good to go. As far as computer hardware, I think David was using just your run-of-the-mill type of laptop. When you're buying a laptop or workstation with point clouds, one of the most important parts is the graphics card, because point clouds are a little heavy on graphics cards. However, W520 laptop, and I can make it run just fine. It has a regular processor on there. It has 8 gigs of RAM with an NVIDIA Quadro 1000M video card. So something like that or better certainly will help, but it doesn't need to be anything super special.
So basically, any workstation that would run Revit otherwise should be suitable for running these large point clouds through CloudWorks inside of Revit.
Exactly.
Yeah, definitely.
It says that Cyclone is managing the cloud. So Cyclone's doing all the work managing the cloud. Revit isn't managing anything. However, that with the point cloud being in there through CloudWorks, Revit knows there's a point cloud in there, so the Revit point tools are interactive with the cloud.
Okay. Now, on the topic of CloudWorks and Revit, the question has come in, does CloudWorks for Revit need a separate license, or is it licensed under the regular CloudWorks license?
Yeah, so there's so many copies of versions of CloudWorks. Each one is licensed separately. So, like David said, there's one for AutoCAD, there's one for MicroStation, and we have them kind of 3ds Max, Maya, et cetera, et cetera. We have several of them. But in the CloudWorks for Revit does have its own license, yes.
Okay. Now, let me ask David, as a product developer. So, what is pardon me? We've discussed hardware, but what about the operating system requirements? And I'm sure plenty of our listeners would like to know about the upcoming Windows 8 compatibility.
Yeah, definitely. It's Windows 7 has been a really nice platform, and now the ability to run 64-bit, which Cyclone now is 64-bit as well. So we will definitely be, to, testing on any new Windows platforms that come out, and we will be supporting those, as they become available. Currently, Windows 7 is the preferred OS. Nothing on any Mac computers.
Okay, so not Mac compatible yet, but definitely all of the flavors of Windows, and hopefully in the future all of the flavors of Windows.
Yeah, most definitely.
Okay. Let me ask Jason, can you give me some real-world experience on, we've witnessed the process, and we've been discussing optimizing these point clouds, and point clouds are very large overhead. When point clouds started showing up in AutoCAD, one of the complaints was that we've got slow performance of rendering, and of course that's improved. The AutoCAD point cloud engines improved vastly. So what about with Cyclone and the viewing we saw that we can change views and store views and restore views? What are your real-world experiences? What are some of the challenges that you've had, and how did you get around those? And how did the scan to Revit workflow work to resolve those?
Yeah, there's just in general working with scan data, there's challenges. The files are enormous. There's millions and millions of points. Most typical I'd say computers are probably not going to be able to handle them that well. Anything, obviously, that you can run a Revit with or build a decent Revit model with can handle a scan. Like Ben mentioned earlier, there might be 600 scans, which is really nice because it parses them down into smaller pieces. And then with CloudWorks and Cyclone, you can bring each one of those pieces in individually, and you might not have to bring in the entire scan, which could be a terabyte.
Wow.
Obviously, storage is a big issue with the amount of data that we're handling, but being able to bring them down into little bite-sized pieces is very beneficial. And obviously being able to clip them down and make them as small as possible in each instance, and then you're just taking care of a section at a time.
No, would you agree with that, Ben? Is that been your experience?
Yes, certainly. I mean, I can show you a couple of images of a real-world project if that would help, just to sort of illustrate it.
That would be fantastic. Let's look at some real-world work here. We're getting control transferred over to Ben, and we will have some illustration here. In the meantime, now, just very quickly, Jason, you were mentioning the massive size of some of these points. And do you find that the CloudWorks is handling these really large data sets well for you?
Oh yeah, like David and Mike had mentioned earlier, Revit doesn't manage the cloud. Really, Revit doesn't even really know the cloud's inside of it. Cyclone handles all of the background information, and having Cyclone on your computer is definitely not a bad thing. When you open the scans in Cyclone, you can really maneuver it very well. It handles large amounts of data very easily. So yeah, it's definitely easier to work with that way.
Now, Ben, we've got a picture of a very pretty, I'm assuming British building.
That's correct, yes.
Okay,
yeah.
I didn't see any bobbies or anything, but I that was probably.
Yeah, this is a shopping mall in the UK that we were commissioned to produce a BIM model for as part of a Scan to Revit project. And this is sort of an idea of the ground floor layout and a number of scans. It was a pretty big project. There was sort of 500 plus scans on it. So the main issue was just managing this amount of data. So that's our data, how we would like to view it in Revit, but unfortunately, it's not. We weren't able to bring it in its sort of raw, full, unreduced format. So these are just a few slides showing the sort of level of information that we captured.
Wow.
So we would have to split this down into lots of different point clouds, lots of different files by floor, maybe by individual department stores, and we'd have maybe 20 individual point cloud files, which all have to be referenced, indexed, and then brought into Revit individually.
Wow.
So the problem that we have, these images look lovely as they are like this. When we actually then bring them across into Revit using a native support, this is what we're presented with. We don't have any intensity values. We just have a big mass with one solid color. So it then becomes very hard to really interrogate it and work out what you're looking at to model from. So one of the things that really assisted us and supported us with the modeling is we actually use a TrueView application, and we have that as a background reference to allow us to really visualize what we're modeling. If anyone's not familiar with TrueView, it provides you a 360-degree image from every scanner location. So we use that as a reference to assist with the modeling. And as you can see again there, it's in sort of just a one mass color. So it's a time-consuming and a tricky process, and can potentially be error-prone without using something like TrueView to reference from. But you can still get good results, put the time in, and it sort of gives you an idea of what we finally built up from it.
Wow, that is
and
fantastic.
build a full model.
It's amazing the advances that scanning technology has made over the years. Now, looking at the size of the project that you're showing us actually leads me to one of our questions from a listener. And the question is, how does CloudWorks for Revit handle point clouds with large coordinate values? Does CloudWorks for Revit handle state plane, which I'm not sure that you can answer, Ben, in the Revit environment? So obviously you have, this is not a small project. How does CloudWorks handle large coordinate values?
Sorry, so I was just looking at my screen back there. Yeah, I don't know if one of the other panelists might be able to assist on that question better.
Sure, I can actually help answer that. All of my projects that I work with, I model in state plane. We don't do a project that's not in state plane, just because of civil is obviously modeling in state plane. If we model in state plane, energy analysis, there's so many benefits to modeling in state plane. Plus, any government agency wants their models in state plane. So if we use consultants to do our laser scanning, we just tell them we need them set up in state plane. They go find coordinates on site. And obviously, like you said, the state plane coordinates are huge. The numbers are in the millions. And if the scans are registered in the state plane, you bring them in, even if they're pieces and parts of the scans, they come in and fall right in the exact same place in the model, right on top of it. It's actually very nice and works out perfectly.
Okay, fantastic. So looking at another one of our listener questions, I'm going to ask Mike, what is the long-term cost and the kind of the period of implementation for installing and really bringing CloudWorks for Revit online?
Well, you have the upfront cost of the software itself, which is it's around $4,500 or so, and then you have a yearly maintenance fee, which you get all software updates that we do to the software as long as you have you're current on your maintenance plan. As far as getting up to speed and learning the software itself, the main hurdle is learning Revit. For somebody that doesn't know Revit, that's the main hurdle. For anybody the expert in Revit, they can pick up the CloudWorks stuff very quickly. And also that both myself and David, we produced an online tutorial for the CloudWorks for Revit that is free that anybody can use. So.
Okay, fantastic. Now, and again, I'm sure you have these questions posed to you all the time. And one of our listeners is asking, how long does it usually take to produce a complete model, start to finish? Let's say for a McDonald's building, for example. I think we should assume that this is for an experienced Revit user. So, what would you think is this? Actually, I guess a more fair question is, what kind of percentage can an experienced Revit user, time-wise, look to save on a project?
Quite a bit. The main thing is that your traditional ways of collecting data is always going out with either a total station or tapes or those types of things, and the danger is of missing things out in the field. With the laser scanning, it's a indiscriminate way of just blasting the points with blasting the site with points, if you will, and it gets everything. In the office, again, it's as fast as you can draft. You will definitely see a huge difference from field collection and quality of data that you're getting back. And then once you have it into the CAD platform, it's as fast as you can go. Get it out.
Okay. Now, Ben, what type of real-world time savings have you been experiencing?
Yeah, well, we've had a real change in our workflow, whereas in the past the site time was very time-consuming, and to do an ornate building, a lot of the time it wouldn't be cost-effective. Now, by using scanning, we can really do surveys very, very quick on site, and we tend to work to a ratio of probably 1 day laser scanning equates to about 5 days modeling time for a very detailed Revit model.
Fantastic. And Jason, are you experiencing similar changes in your workflow? What has been your experience?
Yes, the very similar. It's a much faster process. There's not as much go back, I guess. You don't have to spend as much time out on site. You scan it. Really, the scanner is doing all the work. You move it to the next location, do the scan. And then once you have that data, you really don't ever have to go back and visit the site again. You can measure any coordinates or dimensions you need. You can get right off the scan. There's no go back and check something. Usually it comes with photographs as well, so you can really have all the data that you would need in one fell swoop.
That really must be quite a time saving. It's always very costly in terms of time to return to the site and get additional survey. I don't think anybody ever likes to do that. Mike, we have a question specifically posed to you, and now if somebody else has a better answer, please do chime in. But how accurate is the model in terms of scale?
As far as scale, the model is on. You're pretty much drafting on top of the points. The Revit snap-on points is active because Revit does understand that there's a point cloud there. So, it's one of those challenges that in the real world, walls aren't exactly perfectly 90, 45, those types of things. And Revit is a little difficult when you're modeling those types of things. It would be, the model that you're going to get is just as accurate, if not more accurate, than you would get with any traditional means of measurement, via tape or total station, that type of stuff. So it's just that you have, this, instead of, if comparing to, let's say, a total station where you have a point on each corner type of thing, you have now possibly hundreds of thousands of points along the wall surface that you can go ahead and look at and model and average. And also that one of the tools that is in there is you can actually place working planes that are averages of all those points that you can place your walls on.
Okay, well that's fantastic. Personally, I'm 5'8", so I measure everything in terms of curts. This is 3 curts, that's 2.5 curts. So that's my personal unit of measurement.
If I can say one thing on the accuracy there, Kurt.
Yes.
Yeah, I think the accuracy really comes down to the project in hand. You can really model it you are constrained slightly with the software, but if you want to take your time and you can model as closely to that point data as you want. So it really depends on the project and what the client's deliverables are. It might be that in a typical BIM project, plus or minus 20 mil is an acceptable tolerance for that project. It might, in other projects, you might need a much tighter accuracy, and it just comes down to time and cost and how long you want to spend on that model. You can achieve a very accurate model. It comes down to time, really.
Okay, so I guess everything does come down to time. Ben, as long as I have you front and center, I do have a question specifically for you from one of our listeners, and let's see. That question is, what is the time frame for the mall that Ben showed us?
For that model, we had there was well over 500 scans, and we did about 10 days on site laser scanning, and it equated quite nicely to around 500 hours of modeling time. So that was sort of three Revit guys on for 4 and a bit weeks. So quite an intensive project, and that was really a lot more detail than we would normally go to on a standard project. On that one, we modeled the stone coursing. We'd even put in things like CCTV cameras and a lot of additional external features that we wouldn't necessarily put in on an everyday project.
Well, I tell you, it sure did come out looking great. Now, I have a question for David, who probably thinks that he's off the hook here, but he's not, because since you are our CloudWorks expert, I have a question from a listener, specific, right up your alley. The pipe generation tool is interesting, but can it be done for built-in elements too, or must built-in elements, i.e. walls and floors, be traced only?
Currently, yeah, we only do have a few fitters, automatic fitters, like the pipe fitter itself. All the other, well, with walls, we do have the ability to automatically find the plane of the wall, and then you can, sketch and draw out the wall from there. So, however, yeah, we don't have any kind of fully automated, features yet for walls or things of that nature. We kind of, we're going to start, once we start getting some more feedback, we wanted to just get this product out there, and once people really start using it and putting it to work, in the real world, we're going to start getting some good feedback, and then that's, the direction we're going to go of what kind of, automated fitters do we need, what do we want to add to it from here on out.
Okay, so that definitely a possibility.
Yes,
okay.
Definitely is.
Hand in hand with that, we have another question that I personally find it very interesting. Are there tools in CloudWorks or Revit that allow one to model something that is not rectilinear, but more organic in shape, such as a sculpture?
Yes, I do. I know that is being done, so maybe one of the Revit experts can better answer that, but I know there is a way that what I have talked to a few customers that are doing is they're using this auto plane fitter, so they're fitting a work plane to the point cloud, and then you're able then to use that to start modeling, ornate shapes, and then build your model that way. But maybe one of you guys can answer that a little bit better.
We've certainly used third-party packages, things like 3D Reshaper or Geomagic to mesh a point cloud, and then bring a certainly reduced mesh into Revit, but it is just a dumb object. So you can use it as a visual purpose, but you can't physically do a great deal with it. But in certain instances, we just want to show a more organic shape in there. We've used that workflow.
Jason, have you had experience with organic shape modeling in Revit?
I'd say, there's obviously the mass editor, which will do some of that, but nothing that's automatic. Like Ben mentioned, I've done the same thing, is use a third party, more of a modeling tool that meshes it, and you bring that in as a dumb object.
That's what I was looking for, is the mass editor. That's how some customers are actually building walls that are, off plumb or whatnot. So they're fitting a work plane to the point clouds, and then from that work plane, they're able to use the mass editor and then build the wall that way, so that it's not a perfect 90 wall.
Okay. Now we're starting to get into the last 5 minutes of our webcast here, and we've got just questions flowing in. So let me try and fit a couple of these in. For anybody who would like to answer, what would the average number of scans per room in a building be? Now we've heard men talk about 500 scans, and yeah. What would you say the average conference room? What would that require?
Part of our workflow, for every room we go into, we do a scan in the center of the room so we can pick up a good view of any windows in there, and then we do a scan in the doorway to join it. So obviously, depending on the size, we can, if we want to calculate the number of scans in a project, we just look at the floor plans and put a scan in every room and a scan in every doorway to join it together, and we can quite easily work out the number of scans for a project.
Does anybody else have thoughts on that? Does that pretty much cover it?
Yeah, that pretty much covers it. I mean, it's pretty much like, each room being different in size. Your standard room, you can do as little as Ben said, just one in the middle, to do, maybe just a couple at a lower resolution type of thing to capture more detail. But maybe minimum one, maybe maximum 3.
Okay. Now, we're getting right down to it, so I have one question I really think is pretty interesting. If you send a drawing from Revit with one of these models, do you have to send the Cyclone database similar to an e-transmit where an XREF is also sent along with the drawing? So I'll pose that to Michael or David.
No, you don't. The Revit model is, completely disjoined from the point cloud if you're wanting to send the model out around to other clients or whatnot.
Now, in that situation, would they be able to restore points that have been hidden from view the way you demonstrated?
They would not be able to do anything with the point cloud. They would not have any notion that there was even a point cloud there or that it was, built with the point cloud itself.
Okay, so the transmitted file would be sans the Cyclone CloudWorks data.
No, it would just be the Revit model. So
okay.
you're not looking to transmit the actual scan data, correct? You're just looking to transmit the model?
I imagine that the origin of this question has to do with file size. Of course, email, sure. How can you, and sending it up to the cloud itself.
Yep.
So I think that what I'm hearing here is that if you send the file, if you send the Revit file, none of the point cloud data goes with it. Ergo, the file will not be inflated in any way.
Exactly. That is correct.
Perfect. Well, I tell you what, gentlemen, we've got just under a minute and a half here. I want to take a moment to thank all of my panelists. Ben Bennett, Chief Technology Officer over at Digital Surveys. I want to thank Michael Harvey, Product Marketing Manager with Leica Geosystems, and Mr. David Langley, also with Leica Geosystems in the Application Engineering Department, and Jason Waddell, BIM Manager over at the Beck Group. I want to remind all of our listeners that if your question did not get answered, that we've captured all of these questions, and we're going to be sure and trying to get back to you and get those answered, or you can follow up directly with Leica Geosystems or Cadalyst. And our conversation today is going to be archived on Cadalyst at cadalyst.com/point-cloud-Revit. You can see that URL on your screen. I'd like to thank everybody for taking time in their busy schedule to come and listen to us discuss optimizing the use of point clouds for Revit modeling. And we hope that you'll join us again for our next panel discussion. Gentlemen, it has been a pleasure and an education. I'd like to thank each and every one of you, and good luck to all of you.
Thank you.
Thanks to all.
Thanks,
all right,
guys.
thank you.